All right, so we're going to get started with exercise 202 today. It's a little different than 135. For those of you that have been in 135, you know that I usually started with a lecture and then I did demo. In this class, it's really much more about demo and showing you how to work with the program and that sort of thing. So we're going to spend a lot of time jumping right to Rhino and V-Ray, working through kind of how to go about doing the things that I'm asking to do. So the other critical part about learning Rhino is that I have to come into this, since there's no prerequisite for this class, I have to come into it assuming that you have no experience whatsoever doing anything in any kind of a computer drafting program. So that means that I have to assume you have no experience in AutoCAD, I have to assume that you have no experience in Rhino, so we have to kind of start all the way back at the basics. So for those of you that were in 135 with me, if you flip exercise 202 over, you will see a floor plan that looks shockingly familiar to the one that you worked on in AutoCAD in 135, and that is because essentially we're doing kind of the same thing. So today we're going to take a step back from our three-dimensional work that we did last class, and we're going to concentrate on just basic two-dimensional drawing techniques, learning how to use the Polyline tools, and learning how to work with those basic tools, understanding the coordinate system and how it works in Rhino, similar to how it works in AutoCAD. But like I said, I have to assume that you guys have no experience in any of this. So, that being said, I'm not under the delusion that it's going to take you the full lab time, or all of you the full lab time to do this exercise. You also aren't at a point in your classes such that you have a bunch of extra work to do, so I'm not going to be a stickler about sticking around and working on other work, etc. Today. Next week, we start to get into where you probably have other things to do. Even if you don't think you do, you probably do. So I'm going to start encouraging you, even if you finish early, to stick around. You'll have to, for those of you that pick up on Rhino really quick, you'll have to bear with me while we get through the first couple weeks, just trying to understand the basics. Remember that I spend a lot of time thinking through what tools I think are the most valuable and making sure that I teach you those tools. Usually there's a set grouping of tools that I really want you to get out of each day. That being said, those are tools that we will build on the next day. So if you're struggling to understand a particular tool, let's work through it. Let's make sure you understand it during lab that day, because the next day it's important that you really understand that tool and can use it, because I'm going to ask you to use it without going back and re-explaining it. It's part of how we get to the end of the semester and how you guys get the ability to model some complex stuff in Rhino. So today we're going to work on just 2D basic drawing. When we go ahead, I don't have a template file for you to download and get started with. Well, we're going to start with a brand new file, so I'm going to go through the whole process starting with a brand new file for you. I already have Rhino 6 open on this computer. I'm going to go ahead and go to File and then New, and that's going to bring up the Open Template File dialog box. Rhino has a bunch of built-in templates that you can use depending on what it is that you're modeling, because Rhino is very flexible in terms of the scale of what it is that you're modeling. We're going to be working in large objects with inches as our default measurement. That'll be the case throughout the whole semester. The size of the objects is such that that is an appropriate template to start with. So it'll always be large object, inches, and I'll go ahead and click on Open. That will open a new file with the large object inches as our default template. We can notice down here at the very bottom that our default inches, or default units, are in inches. I know it's right behind my head. It's a terrible place for it on the screen, but that's telling us, yeah, okay, we're in the right place, we're in the right units, so we're good. So that's set up as inches. All of the drawing that we're going to be working with today is going to be in the top view. We're not going to work in the perspective view, though technically speaking you could draw in the perspective view and get the same thing. But since we're talking about 2D, I'm going to force your mind into just working 2D. So we're going to jump over into the top view. So I'm going to make that my largest viewport by double clicking on the word top. So the viewport label top, if I double click, will make the full size of the page. And now I can zoom out a little bit and I can see my grid and get started. So the grid is there really as a guide. It's there to help you out. I don't think I ever use the grid in any capacity other than to see what seaplane I'm in. I'll explain seaplanes as we go forward. That's really the only thing I ever use it for. But it's there. You can turn it on and turn it off if you want to. I would just leave it on in the background. You're going to stop paying attention to it and just kind of ignore it. So we're going to go ahead and we're going to start drawing. And we're going to work by drawing using some coordinates. So Rhino, just like any other really high quality 2D drafting program has a mathematically driven formula behind it. So everything that we draw works based on coordinate systems and grids. This is very much what you learned way back in like algebra when you had to graph basic functions and that sort of thing. We're working with a coordinate system in the same capacity. Rhino has 3 coordinates. We have an x coordinate, we have a y coordinate, and we have a z coordinate. Z is the 3rd dimension. It's the one in our current view, top view, that's facing toward us. It's coming up toward us. We're not going to be drawing anything in the z dimension, so everything today is just going to be in the flat x and y dimension. When we talk about coordinates, those coordinates are always listed as the x coordinate followed by the y coordinate. So if I was picking a point, let's say this point here, it would be x of 3, whatever those 3 units are, and a y coordinate, so going up here, of 1. So this point here would be 3 over and 1 up, and it would therefore be represented by 3, 1. So we're going to use that same strategy as we move forward. So I'm going to start using the Polyline tool, which is the next tool below the arrow tool. And when I click on that Polyline tool, I'm going to come over and I'm going to start to draw. And the reason those coordinate systems are important is because even if I think, oh, I'm really good, I'm going to zoom in and I'm going to pick right at that origin point, I'm going to start right there. Yep, that's on it. As soon as I zoom in a little bit more, I'll see, well, wait a minute, it's not really at the origin. If I were to zoom in a little bit further and I went back and I said, let me do it again, okay, this time I'm going to be really good and I'm going to be on that point. Yeah, that's it. Now when I zoom in, guess what? It's still not there. So no matter how much you zoom in, you're always going to be off. So we're going to use that coordinate to our advantage. So instead of trying to pick that point, we're actually just going to use our polyline and then type in the starting coordinate, which is 0, 0. And I'll type it in like that. It shows up in my command line up top, and I'll go ahead and press enter. Now, no matter how far I zoom in, it will always be right at that starting place. So it's important to get used to turning that in. The coordinate that I just input is called an absolute coordinate because it's relative to point 0, 0 on the grid. So it's always relative to that point. So I'm going to continue, and in this case I want a line that is 24 feet long going right up in the y direction, right here. And so if I want that, I'm going to type in another coordinate of that next point. And that coordinate in absolute coordinates is 0, 24 apostrophe. Or 0, 24 feet. So I'm typing that value in. The apostrophe, the single apostrophe, is for feet. The quotation mark is for inches. So you can get used to doing that. Though if you leave it off, if you leave the inch mark off, it will assume inches. So you don't always have to put the quotation mark on. So when I type 0, 24 feet and press enter on the keyboard, I have to zoom out a little bit to see it, I get a line that is exactly 24 feet long going up in the y direction. I can continue here by typing another coordinate. If I want a line that goes over 12 feet here, I can type in the coordinate of the end point of this line, which would be 12 feet in the x direction. So I type in 12 feet, 24 feet in the y direction. And then I'd press, oops, sorry, I'm not typing clearly here. 24 feet in the y direction, and I'd press enter, and that gives me that next point right there. So I was able to use absolute coordinates to figure out where those points are. So the absolute coordinates can be great, but they're always relative to point 0, 0. So maybe you're way off in space somewhere and you don't have the ability to reference point 0, 0. Or you don't know where point 0, 0 is. We can do something called a relative coordinate, which resets where 0, 0 theoretically is to the last point that you clicked. So it's relative to this last point that I clicked. So where do I want to go? So in this case, I want to go down by 6 feet. So to initiate a relative coordinate, I'm going to put the @ sign. So it's like an email sign, so the @ and then I'll type in my coordinates. So in this case, relative to the last point I clicked, if I want to go 6 feet down, I would say @ 0, -6 feet, because I'm going down the 6 feet. Now when I press enter this time, it's going to give me that line. So it's key that I put in that @ sign. That's how it's distinguishing between a relative coordinate and an absolute coordinate. So if I was going to continue on here and I wanted to draw a new line that was 12 feet going off in the x direction here, I would say at, so relative to that last point that I clicked, this time it's going to be 12 feet in the x, comma, 0 in the y, because it's not going up or down. And I can go ahead and press enter. And that gives me my next coordinate. I should point out on the little handout here, just sometimes this is self-explanatory, but I'll try to be consistent with this throughout the semester, that whenever I talk about typing something in to the command line, the font changes to the little typewriter font. It's bold and it has a little typewriter font to it. That way you know that I'm talking about typing in that particular value. So I try to reference that. Same thing is true on the course website. If we went to today's exercise, right here, I always try to switch the font out so you can see it's like a typewriter, like I put it into the command line. So I'm trying to make it a little easier so you guys can see that as we go forward. Okay, so continuing on, if I wanted a line that was going down here by 12 feet, I can use that relative coordinate again. It would be at, again. This time we're going 0 in the x direction, and we're going negative 12 feet in the y direction. And I'll go ahead and press enter. And that gives me that line there. Now I can switch back and forth. I still know where 0, 0 is, so I could figure out what this point is in absolute coordinates. So I can toggle back and forth. In this case, the absolute coordinate for this corner would be 12 feet, comma 6 feet. So I'm not going to put the at sign in here, and I'll just type 12 feet and then comma 6 feet. So it's over 12 and up 6. Apparently I can't type. And then press enter. So I'm just flipping back and forth. So this one down here would be an absolute coordinate of 12 feet, comma 0. And then I can come all the way back to where I started. We want to make sure that our snaps are turned on, which mine currently are not because it was a brand new file. I'm going to turn on end, mid, and perpendicular. And I'm going to do that before I try to snap to this endpoint. Now that I'm there, I can snap right to the endpoint and click, and it's now made my object. Now you'll see that it's missing a few lines. You see that line up at the top that's missing, and this line here that's missing. That's that OpenGL error, and I always forget when I first started up to change that. It's we can change it by going to Tools and then Options. Under View here, I'm going to pick OpenGL, and I'll uncheck the GPU tessellation. And now I'll see all my lines. I apologize that we have to do that and that the tech support IT people haven't figured out how to make that permanent. So I've drawn this shape, which is the basic outline of my building. To me, that's a good introduction to what absolute and relative coordinates are. For the most part, we're not going to use them. I'll show you how we would typically draw this shape. But there are cases where we need to be able to draw based on those kinds of coordinates. If I was drawing along, let's say I was drawing some kind of a shape, let's say 10 feet, and then I went over, hold on a second, let me turn on ortho here. I go over 5 feet, and then the next piece I wanted to come down on an angle. That's a perfect opportunity for at, let's see, negative 5 feet, comma, negative 10 feet. And that then lets me draw that piece on an angle. So it's a really good strategy to have just in the back of your head, because sometimes it's important depending on what it is that you're drawing. So I'm going to go ahead and delete that. So let me show you how I would go about drawing this shape in a little bit faster way without having to type all those coordinates in. So I'm going to delete that. Doesn't mean you have to delete it. I'm just showing you these various methods here. So I'm going to go back to the Polyline tool. And I'm going to start by pressing 0, 0 again. So I'll start by initiating it right at the origin. And then Rhino has essentially what it will do for us is it will allow us to type in a distance and then choose a direction. So in this case, I know I need a 24-foot line, so I'll type 24 feet followed by the enter sign, and then it'll ask me what direction do I want it to be in. So if I have my ortho turned off, I can have it draw in any line that I want. If ortho's off and you press shift on the keyboard, it will jump to have ortho on temporarily. So that can be a strategy. Some people like to do it that way. The other thing, depending on what you're drawing, sometimes you just turn ortho on and it sticks to your 90 degrees. So there I am, 24 feet going up in the Y direction. I can now type a next distance, which would be 12 feet. And I want to go in that direction, followed by 6 feet. And I'm just clicking in the direction that I want. 12 feet, click, 12 feet, click, 12 feet, click, 6 feet. You get the idea here. It's pretty fast. So I'm going to make sure that I snap right to that end. If I had my snaps disabled, I'm going to disable them for a second, and I said, okay, well, I want to try to I'm just going to pick where that end is. No matter how careful you are, you're never going to, it's just like trying to start at that origin. You're never really going to get to the end. So you want to make sure that those object snaps are on and that you snap, and there it is, snapping right to that point. And there's my initial shape. So at this point, we need the second part of the line. So we have the exterior wall established. We want the interior wall established. We're going to assume for the moment that it's a 6-inch thick wall. That's not quite true, depending on what type of building materials you're using, but we're just going to use generic terms. So we'll assume it's a 6-inch wall. And I'm going to use the offset command to create my second line. So this currently is all a joined polyline. It's all one continuous line. I'm going to make a second copy to show you how things change here. And this one over here is all made up of individual lines. So when I go to do my offset, I'm going to either type in offset. I can go to curve and then offset, offset, curve. Alternatively, I could come down here. It's got to be one of the tools, but I never pick it from the toolbar, so I don't really know where it is. It's probably under one of these. No, that's trim, split. Well, whatever. Type offset or choose curve, offset, offset, curve. It's going to ask me first to select the curve to offset, or what do I want the distance to be? So in this case, I want to specify the distance first. The distance is set for 1. That would be 1 inch. I want it more than that, so I'll click on distance, or I could type D, which is the capital letter there. That's the keyboard shortcut for it. So if I click on distance, I can then type in what I want my thickness to be. Now I could type in 6 followed by inches, or I could just type in 6 because it's assumed to be inches because my default units are in inches. So I'll go ahead and press 6 and then followed by enter on the keyboard. And then it once again comes back to select curve to offset, but my distance is set for 6 inches. So now I can select my curve. I'll select my curve. And then it's going to ask me which side do I want to offset to, the inside or the outside. So all I have to do is click on one side or the other. So I'm going to click on the inside because that's the side I want to offset to. And I get my second line. And you'll see that that second line is also a continuous polyline. Alternatively, if I came over to this shape and I repeated that offset command, my distance is still set as 6. But in this case, I would be picking individual lines, and I'd have to offset each one. Oops. By the way, you can repeat the command by right-clicking, so that's what I'm doing. I'm right-clicking to repeat the command. And I'm working my way all the way around this shape. So in this scenario, right, I have all these overlapping lines. I would have to go in and I would have to trim all of these to get rid of them. So it's a lot of extra work. So joining it first and then doing the offset is usually a better strategy for how you create it. Yeah?
Great question. I don't know if you mentioned this earlier, but when I made the shape, the top line and the bottom line.
So if you did that and the top line and the bottom line disappeared, it's an artifact that happens with these computers. If you go to Tools and then Options, go to View and then OpenGL and uncheck that GPU tessellation. Okay, so I've gone ahead and I've done that. I'm going to delete this shape because I don't need the backup there. And so now I have the outside wall and the inside wall. It comes time to put the doorway in. And you can see on the back the drawing that I'm modeling this after. But essentially I've got a doorway that's 3 feet that is in the center of this top wall. So given that I have a doorway right in the center, I'm going to start by drawing a line, and I use the Polyline. I could just use a regular line segment, but the Polyline works the same. I'm just going to press enter when I'm done. And I'm going to draw that from the middle of this line to the middle of that line. Now I currently have my object snaps turned on and my midpoint snap selected. And because I have that midpoint snap selected, it will snap right to the middle of this line. So I can go from there, and I can come down there to that point. Now when I'm done, I'll press enter. If I were using just the line tool, which is right here, it would end after the line is over. So it's one extra enter using the Polyline tool instead of the line tool. I'm so used to it that I don't even think about it. So there's my line. It's in the middle. I need now to establish the opening for this door. So the opening is 3 feet. So I'm going to need to do an offset from this line. So I'm using the same tools that I just used to create the wall. I'm using it again. So I'll type in offset, or I'll go up to curve, offset, and then offset curve. And it's going to ask me first, what distance do I want? Well, half of 3 feet would be 18 inches. So I can go ahead and type in 18. Alternatively, I could type in 1 foot 6 inches. That would work. I could also, how about this, type in, what is it, 0.5 times 3 feet. And it should do it. Nope, it didn't like me. You're supposed to be able to do some math in there. Anyway, didn't want to do it, so we're not going to worry about it. Oh, no, it did do it. There we go. I typed in 0.5 times 3 feet, and my distance was set to 18. So there's lots of ways to do it. So I could do it in a math equation like that. So in this sense, my distance is set to 18. That's what I wanted. Now, I could pick the curve and go one way, and pick the curve, and repeat the command and go the other way. But Rhino also has the ability, when I'm doing the offset here, to select right here both sides. So if I type B followed by enter or click on both sides, it will do the offset in both directions at once. So it saves me a step. It's kind of nice. So I can go ahead and do that. It gives me both sides. At this point, I can also go ahead and delete that original line because I don't need that anymore. So I'll press the delete key. So I have this side and I have that side. We want to go ahead and cut the opening through the wall. So I'm going to use the trim command to do that. I can type in trim. I can go to edit trim, which actually has a keyboard shortcut, Control T, if you want to. I can type in trim, or I can pick the trim tool, which is available right here. This trim tool works a little bit differently than AutoCAD in that it specifies different, you're not just selecting objects. In this case, I'm selecting what is doing the cutting. So in this scenario, this and this are doing the cutting. So I've selected both of those, and I'll press enter when I'm done. And then it says select object to trim. I would click on this object and this object. When I'm done, I'll press enter, and that gives me the cut through. So a little bit more about how things are selected, and this is a good opportunity to explain this. I can select one object, I can hold down shift, and I can select the second object to select two objects. I can click and drag a box from the left side to the right side and select only the objects contained within the box. So when I do that, see how that box completely contains these two objects and selects only those two objects. If I click and drag a box from the right side, however, anything the selection box touches will be selected. So it's a different way of selecting. So I'm using those as my trimming objects. So when I go to trim, I'm going to go from left to right to select both of those objects, and I'll press enter. If I want to cut through these, I can pick them individually, or I can make a selection from right to left, and anything that it passes through will get trimmed at once because I'm selecting both at the same time. So it can be a little bit faster. In this scenario, does it matter clicking twice versus clicking once? No. But if you imagine having 100 lines that all needed to be trimmed off, it's a lot faster to drag a box through from right to left to select them all. Okay, so I've gone ahead and I've made that. I'll press enter to finish the trim. And the next thing that I'm going to do before I move on is I'm going to join this little line segment to these line segments. So in this scenario, I'm going to select from right to left to select everything. And then I'll go up to Edit, Join. Alternatively, I could type Join or press Control J on the keyboard. And that's going to join those into one continuous polyline again. This doesn't matter so much when you're just drawing 2D, but as soon as we start to make it into 3D, being clean with your drawing and making sure that everything's joined will help in your three-dimensional drawing. We will save this file and we will work on it going forward. We'll eventually make it three-dimensional. So you'll follow along the steps as we go. So I've gone ahead and I've cut the doorway open. I'm not going to worry about drawing the door just yet. I'll show you how to do that a little bit later. But the next thing that I need to do is I need to draw in the windows that are on either side of the door. So in this scenario, there's a 2-foot window. It's 1 foot from this door, and it's 1'6" from this corner. And I need to be able to draw that window in place. So what people often do is they take the line, or the polyline tool, and they say, okay, I'm going to click on this corner, and I'm going to draw over 1 foot 6 inches, and then I'm going to draw down. Notice I have perpendicular selected, so it'll snap to the other line perpendicular. I'll press Enter. Great, I've got my line. The problem here is that this line is not a single line segment. We've got this line on top of it. And so if I were to switch over into 3D, and we're going to do this next class, and I were to take this corner and I were to say, okay, I want to make this three-dimensional, as soon as I do an extrude on this, right here, it's going to make an object that has, let me switch over into shaded so you can see it a little bit better, that has this leg on it, this extra piece that I don't need. Likewise, if I were to extrude this on top of it, now I have two surfaces right on top of each other, there and there. And as soon as I go to render it, I'm going to get really funky rendering results because I've got two surfaces that are right on top of each other. So I want to avoid doing things like that. And I'll do that using something called SmartTracking. And this is something to get used to in Rhino because it's really going to help you out a lot. So what I'll do is I'll click on the Polyline tool and I'll hover my mouse right over this corner. And as soon as I do, you see that that little point turns white. At that point, I haven't clicked, I just hovered over it. I'm going to move my mouse to the right, and I now get a blue point with a white line next to it. I can now type a distance, and it's going to be a distance away from that now blue point. So I can type in 1 foot 6 inches, and it's going to start my line at 1'6" from that reference point. And so I can draw that over. And it's going to give me just the line. No other extra segments, nothing. Just the line itself. So I'll do that again for your reference. So I'll use the Polyline tool. I'll hover over that endpoint. I'll move to the right and type in the distance of the window. In this case, it was 2 feet. I'll come down and I'll snap to perpendicular, followed by Enter. And that gives me this line segment and that line segment. I'll practice over on this side, same thing. I'll hover over this corner, I get my white dot. I'll move my mouse to the left this time. My dot turns blue and I get a white line for reference. And this time it'll be 1 foot 6 inches or 18 inches. I'll come down and I'll snap to perpendicular, and that gives me the first line. Now the thing about Rhino is there's always multiple ways of doing things. So yeah, I did the smart tracking there. I could continue. I could do the smart tracking from this point, go over by 2 feet. Alternatively, I could go back to that offset tool that I just used, and I could offset that at a distance of 2 feet and create it that way. So there's always multiple ways of building the same thing. And you guys will learn as you become more and more proficient in Rhino that there are certain things that you're more comfortable doing and you'll tend to draw that way. And you'll speed up that way. But it doesn't mean it's the right or the wrong way. Part of my goal initially in teaching you guys Rhino is to show you a variety of commands so you can figure out what works for you, what workflow works, how do you draw, what makes sense. So I've gone ahead and I've drawn those two windows. I now need the center of the window, so I'll draw a line from midpoint to midpoint. I'll press Enter. And I'd really rather show the thickness of the glass than just a line at the center. So I'll use my offset command again. Curve, offset, offset, curve. My distance this time is going to be much less. Maybe it's, I don't know, 0.25. I'm going to offset to both sides to create the thickness of the glass, and then I'll delete the middle piece of glass. So same thing, I can go midpoint to midpoint. I can do an offset, curve, offset, offset curves. There it is. I'm going to do both there, and then I'll delete that curve in the middle by pressing the delete key. So now I have those two windows. So if you notice on this little drawing, there's two windows at the bottom. So way down here. I could just draw those windows as well. But I can also use the mirror command to take this window and have it mirrored down to this side. It's the same distance from the wall, so it makes sense to use the mirror command here. So I'm going to go ahead and go to transform and then choose mirror. Alternatively, I could type in mirror. And when I do that, it's going to say select objects to mirror. It's going to be this window. Now remember, I'm going to make my selection from left to right, so it's everything contained within my object, not from right to left, which would be all the objects. If, however, I made a mistake and I selected all the objects, Rhino has a really unique thing, that is you can hold down the control key, not the shift key, but you can hold down the control key and deselect anything. And the advantage here is that it can be in any order. So adding to selection is shift, subtracting from selection is control. So I've selected just the window. I'll press enter. Then it's going to ask me for the start of the mirror plane. So in something like AutoCAD, it would be the mirror line, because you're working in 2 dimensions. Remember, we're working technically in 3 dimensions, even though this is just a 2-dimensional drawing. So our mirror plane is just a line that has Z to it. So it's tall. And so my mirror plane would be the middle of this building. So I'd pick the midpoint here. Second point, or the end of the mirror plane, would be over here. And I've now created this window down here. I could take it a step further. I could use the same command, mirror, to create a window right here. The difference is that my mirror line, or my mirror plane, is no longer horizontal or vertical. So let me show you that. This is a little bit of a trick. So I'll select this window. I'll go up to transform and then mirror. And this time, I'm going to mirror across this corner from there to there, which gives me the window here as well as there. Could I draw it? Sure. You can always draw it. So I now have that window, this window, this window. The next window is 6 inches from this window. There's 2 windows together. So in this scenario, I'm going to use my copy tool command. And I should point out that there are 2 distinct copy commands that are in Rhino. There is edit copy, and there is transform copy. There's a difference between the two. The transform copy is going to ask you for a base point, so copy from this to that. The edit copy is copy this object and paste it into another file. So we're going to use the transform copy. If you just type in copy, that's what you're going to get. The key command for the edit copy is copy clip, for whatever that's worth. So I'm going to use a regular copy, which is transform copy or type copy. Select objects to copy. I'm going to select this window. Again, left to right. Yeah?
How did you rotate around a corner?
So I used a mirror command across a corner. So instead of, let me jump back and I'll show you that one again. Thanks for stopping me. Sometimes I go through stuff and, I'd rather have you stop and say, wait a minute, what was that? That's not a problem. So, could I draw this? Sure. I could use my SmartTracking. I could come up here by 18. I could draw my window, etc. I could also copy this and rotate it. But the efficient way of doing it is I can mirror, and instead of having a mirror that's horizontal or a mirror that's vertical, if I mirror across a 45-degree line, it's going to bend it around the corner. So that's what I did. I took my object, I went up to transform and then mirror, and I specified the mirror plane as a line that was at a 45-degree angle, which happens to be from that corner to that corner. And it just saves me a step because I didn't have to do a rotate and I didn't have to draw it. So it's just an efficiency thing. So we're back to copying this particular window. So I'm going to select the window, I'm going to go up to transform and then copy, or I'll type copy. Now in this case, what people do by default is they say, okay, well let me just pick the corner of this window, and okay, now I have to figure out how far it is. So it's a 2-foot window plus 6 inches, it would be 2 foot 6 inches, and you can drop it where it's supposed to be. Alternatively though, when I do the copy, if I'm careful about what point I'm copying from, I can save myself some headache. So if I go up to transform copy again, this time I'm going to use SmartTracking but in a different way. I'm going to go to this corner, hover, get my white point, then I'm going to go the distance that I want the two windows separate. So in this case it would be 6 inches. I'll press enter, and now when I come over I can snap to my old window and have the windows exactly 6 inches apart. This is particularly convenient if you have a bunch of windows that keep going in order off into space, where you can just keep snapping and then all of a sudden you'll have windows that are every 6 inches. In this scenario I didn't need all of those windows, I was just showing you what it would look like. So I'll select those and press the delete key.
Could you do that one more time?
Sure. All right, so I'm going to copy this window. So I'll select the window, again, selection from left to right, transform, copy. Now when it says point to copy from, this is, instead of picking this corner, I'm going to smart track from that corner over 6 inches. So I know that the point I'm copying from is actually 6 inches away from the edge of the window. And you can see that little point right there. And so now when I come and I line up to my old window, I know they're exactly 6 inches apart. And then I can go through and I can keep copying over and over. So it's again about being pretty efficient about how you do your copies. So I like to point these kinds of things out because as you evolve and you get more and more proficient in Rhino, you'll start to pick these kinds of tricks up. So SmartTracking is, I told you at the beginning of class today that there were going to be certain tools that I wanted you to come away very comfortable with. SmartTracking is actually the big ticket tool for today. I want you to really understand how SmartTracking works and be able to use it going forward because we're really going to need it. Okay? So a couple more things that I will show you. First thing was how to draw the door. So in the case of the door, I'm going to use the rectangle tool, which is right here, rectangle corner to corner, and I'll pick the corner where the door swing begins. So it's right there. Now, here's a perfect opportunity to use those relative coordinates that I talked about in the beginning. So I need the other corner of this rectangle. So to do that, the easy way of doing it would be a relative coordinate. So I type at x direction first, so it would be negative 1.75. It's assumed to be inches, or I could type the quotation mark for inches, comma, and then how big is the door? It's a 3-foot door, so it would be negative 3 feet. So in this case, because of the location of the door, it's negative 1.75 for the thickness of the door and negative 3 feet for the distance of the door, and that then gives me my door. If I was going in a different direction, let's say I was right here drawing the door, in this case it would be at 1.75, this time positive, comma, negative 3 feet. That gives me that door, followed by enter.
Your drawing has the doors in the midpoint of the walls.
Oh, that's a mistake. It should be out at the end of the walls. Thank you for telling me that. It's interesting. I've probably used this drawing for 6 or 7 years, and nobody's ever pointed that out. It's an error in the drawing. Okay, so I have that door. Next thing I need is the door swing. I need to use a curve tool for that. So I'm right here. It's an arc. Now this center, start, and angle I find really difficult to work with. So I'm going to use one of the tools underneath there for the arc, and it's this one. It's start, end, and direction at start. It doesn't matter whether it's direction at start or direction at end. But this is really convenient because all I have to do is know the start, the end, and whether I want it going out or going in. So I want it going out, and that draws the arc really easily. So it's a good tool for these door arcs. So one more time, it's available underneath the arc tool. It's this one. It's the third one over. Start, end, and direction at start, like that, to create that swing. A couple other things that I'll point out. First one is if you have a line here, and I have another line here, and I want this line to extend over to that line, I can use a tool called extend. So if I type in extend or go to transform extend, it's going to ask me to select the boundary objects. That would be the boundary object, the one that I want it to extend to. I'll press enter, and then select curve to extend. That would be the curve, and it'll extend this over to meet that. It's kind of like the opposite of trim. The other thing that sometimes happens is that you have two lines in space, and I'm going to make these not orthogonal so that they're a little bit more difficult here. And you want these two lines to come together at a point there. I can use a command called fillet. So once again, it's under transform and then fillet. Sorry, it's under curve, fillet curves. Or you could type fillet. The key here is instead of doing a radius, I'm going to set a radius at 0. When you actually have a radius value, so let's say I'm going to do it big so you can see it. Let's say it's 5 feet. It's going to connect this curve to this curve with an arc. But alternatively, I could go back and I could say, you know what, I want that radius to be 0, so I want it to be a sharp corner, and I want to connect this line to this line, and it's going to connect at a sharp point right there. And I can get rid of that curve right there. So you can see how this can help you out depending on where you are in space. So it's just one of the things that I tend to use frequently. Chamfer is similar. The difference here is that you specify two distances. So let's say 2 feet and 2 feet. Let me do the first one, 2 feet. Second one is 2 feet. And then this is going to, instead of making it a point, it's going to clip the end at 2 feet by 2 feet. Just a different option. I'll do it again here. You can see it a little bit better from there to there. It'll clip the end. The distances that I'm specifying is how far from this corner do I want those points to be. So we've already done mirror. The last one that I'll show you is just rotate. It's a regular rotate. It's under transform and then rotate. Don't be confused with rotate 3D. We'll talk about that next class. For right now, it's just a regular rotate. Select objects to rotate. You're going to pick your objects. Press enter when done. Center of rotation. This is around which you want to rotate. So let's say it's this corner. Now, unlike AutoCAD, which jumps to just a standard rotation, this one always asks for your angle or your first reference point. Lets you pick basically the length of the side and say, I want to rotate that to that point there. So it just by default is asking for that angle of rotation or the reference point. So at this point, I'm going to let you guys start drawing. The goal is to get what's on the back drawn using the tools that I've talked about today. If you don't quite finish by the end of class, that's okay. If you breeze through it and want to add some more detail, that's okay too. This is again about feeling really comfortable. The big thing is feeling comfortable with the SmartTracking. That's the big takeaway today that I want you to be comfortable with. Obviously Polyline and trim and that sort of thing too, but SmartTracking is something I want you to have resolved today. So when you're all done for today, I talk about printing to create the image. It actually doesn't turn out very well if you do the print. So instead, I'm going to have you go up to this little triangle here in your view, and I'm going to have you come down to capture to file. And what this does is it saves a JPEG of what you see on the screen. So in this case, this is what I see on the screen. I'll say capture to file. It will save that exact thing. You say OK, and it will then allow you to put it in your flash drive or wherever that you can then upload at the end of class today. So that's how you're going to create the image to upload as your featured image for today's post. So once again, it's this little downward facing triangle in your viewport. Capture to file. It'll show you a little preview. When you say OK, it'll ask you where you want to save it, and it'll save it by default as a JPEG. Okay? So I'm going to turn you guys loose to feel comfortable. Again, today is about feeling comfortable. I know it's back to basics. I know it's not the most exciting thing to be doing, but we have to all get to a certain level before I can start doing the fun pillows and organic shapes, etc. I'm going to pass around the sign-up sheet for today. This will be your official seats for the class. This is where you're going to sit the rest of the semester. This is how I will take roll. This is how I'll know that you're here or not here. So please make sure you fill this out. Make sure you're on the correct computer. Look up at your computer number in the upper left corner of the monitor and make sure it matches. And then when you come in, make sure you sit at that seat each day. Are there any questions about where we are? Nope. I'll let you guys start working.